Alright, so this is a 2011 question 11. I believe it's question 11, either or question. Okay, so this or question is a principle of moment question. So we have this sack truck supporting a box filled with sand. So three of the forces acting are the weight of the box, the effort E provided by the hands, and the force F between the ground and the wheels. So let's mark and label these three forces and show clearly where each force acts and the direction of each force. Okay, so first thing first, let's draw the center of gravity, the W lah. So the W is actually right here. So you must also label, so this W. Okay, next is the effort E. So the effort E is actually in this particular direction. So this is E. Then next thing is the last one is the force between the ground and the wheel. So this is actually your normal contact force. So this is N. Sorry, should be F, because they say that this is F, so I must label as F. So just make sure that the normal contact force is perpendicular to the surface of the system. Okay, so of course take the principle of moment. This one is just pure definition. You just have to memorize it and just write down. So the principle of moment says that the CW clockwise moment is equal to anti-clockwise moment. Right? Okay, part 3, explain how the design of the truck makes it easier to lift the load. So this is 2 marks. Of course, let's see how do we answer that. Okay, if you look at this system, right, you notice that the effort E is rather far away from the pivot. This is what I call the pivot. So the pivot is actually at this particular point. So at this point is what I call the pivot. Let's label it as P. So the effort E, right? So this is a perpendicular distance. So you can see that this effort E is going in the clockwise direction about the pivot. So the W is your anti-clockwise moment. Okay. Next thing is to determine for the perpendicular distance from the weight all the way to the pivot, right, is actually rather short. It's only this distance, right? But for the effort, for the so-called E, is actually this particular part. So it's rather big. It's rather long. So this actually can cause my effort E to become smaller. Okay, so of course, how do we answer that? So first, always look at the number of marks first. Then after that, first point, you just say that, okay, in order to lift the truck, the CW is equal to ACW by the principle of moment. Okay, so next thing you must talk about the point number 2. Point number 2, you just say that, okay, since the effort E, which is providing the CW moment, right? Okay, so the effort E, which provides the CW moment, has a large perpendicular distance, while the weight, which provides the ACW, has a small perpendicular distance. This will cause the effort E to be small. Right, so these are the 2 points to take note of. Right. Okay, now I go on to part B. Okay, part B is actually a rod with a pivot at the center. So they say that two string P and Q exerts a vertical force of 140 Newton at each end of a horizontal rod of 1.6 meter. So the rod is pivoted at the center and the weight of the rod is known to be negligible. So calculate the total moment acting on the rod about the pivot. Okay, so first thing first, there's actually a resultant moment. If you think about this, right, if you look at string Q is actually causing a ACW moment, while string P is also actually causing a ACW moment. So actually for this question, right, this thing is known as a couple. Okay, so this one is more of the A-level stuff lah. Okay, so of course this one we don't need to go to A-level, we just need to apply O-level concept. So first thing you can just write, you can determine what is the moment caused by string P. So this one you just need to know that, oh, this is actually 0.8 meter. So the string P moment caused by string P is equal to 140 multiplied by 0.8. So 140 multiplied by 0.8, let's see, is roughly equal to 112 Newton meter. Okay, so next thing is your Q, moment by Q. Okay, moment by Q is 140 multiplied by also 0.8, because it's 0.8 from the force. This is what I call line of action of the force. So line of action of force all the way to the pivot is 0.8 meter. So this is also equal to 112 Newton meter. So of course you need to add this up to give you the resultant moment of 224 Newton meter. So that is the answer for this question. Okay, so next thing is, this one is a bit more challenging. So they say that another uniform rod of length 1.6 is supported by two strings, R, S. This rod has a weight of 180 Newton, which S is the center of the rod. So S is at one end, and string R is 0.4 Newton from the other end. So calculate the tension of string R. So they want to calculate, oh, what is this string R force? Okay, so first thing first, of course, in every moment question, always put a pivot. There must only be one pivot. So for this, right, maybe I put a pivot here. Okay, I put a pivot here. So why do I put a pivot here? Because if I put pivot here, the tension by the string S is actually not causing any moment. Then after I can apply the principle of moment. Because why I can apply the principle of moment is because the whole thing is not rotating. So it's actually in equilibrium. So I can apply the so-called POM. Okay, so next is, let's determine. Okay, so the 180 Newton force, right, is actually causing a ACW. Then the tension by string R is actually causing a CW. So CW is equal to ACW. That's how we solve this question. So of course, let's write down what is the ACW. So ACW is equal to 180 Newton multiplied by this length. So this length is okay, this length is roughly 0.8 because they say that it's a uniform rod. So 0.8 meter. So it's roughly so it's 144 Newton meter. Okay, next will be your CW. Okay, CW I do not know the force. Sorry, maybe I just put as F lah. So CW is equal to F multiplied by, okay, so the whole of this length, so let's label. So whole of this perpendicular length is around 1.6 minus away 0.4, 1.2. So it's equal to 1.2 F Newton meter. Okay, so I just apply the POM, CW equal to ACW. So 1.2 F is equal to 144. So F is equal to 144 divided by 1.2. So it's roughly 120 Newton. So that is the answer for the tension of string R.